Hi, I'm Joe Hupcey, and I'm here at DAC with Vigyan Singhal, the CEO of Oski Technology. Vigyan, for those of us who didn't get to see our DVCon video, just quickly restate what Oski is all about.
Yeah, Oski Technology is a formal verification methodology company. We specialize in building custom formal verification models written in Verilog and System Verilog and SVA, which help our customers simplify the state space explosion problem, which is a common problem with formal verification tools, to gain higher capacity and solve much larger designs than they'll be able to solve otherwise.
Indeed, and you have years of experience in this space, so tell me give me an example of a challenge there where you would apply some sort of maybe an abstraction methodology to exactly that issue.
Well, there are tens or hundreds of examples like that, and we frequently go into our bag of tricks and pick one or the other example and customize it on a specific customer situation. But to give one example, let's think of a DDR3 memory controller.
Okay, right.
And the challenge with DDR3 memory controller is that there is a well-defined protocol on the DDR3 interface. Mm-hmm. And let's say you're doing end-to-end verification from the internal interface, which could be an ARM, AMBA, AXI, 3XI4 interface. And you want to prove the correctness of transactions as well as the compliance with the DDR3 protocol. And the challenge is that simply the initialization phase of DDR3 takes hundreds of thousands of clock cycles. And it's an unsurmountable problem with formal if you use it in a traditional way.
Right, and that's not really the interesting part, so to speak, right? I mean, that's just sort of initialization, and the action really happens at milliseconds later. Right?
Yeah, indeed. I mean, the most interesting thing in memory controllers and the place where many of the bugs hide is when the different banks of a memory controller act independently and concurrently, and one bank may be pre-charging, another may be activating, and the third bank may be reading or writing. And while they're doing their different things, you want all the timing requirements, TRRD requirements, for example, all of them obeyed and complied by the design. And there is really no way of getting to that state space point in formal without applying these abstraction methods. But if you do apply them, you cover a very, very interesting portion of the design space with formal, which is almost impossible to cover with simulation completely.
Indeed, and I think it goes to, I think a lot of people still think of formal as something that has a challenge with scalability, but that doesn't have to be the case when you apply these methods, right?
Yeah, it doesn't. I mean, in fact, there is a saying that you need a PhD for formal, and 19 out of 20 people in a company do not have a PhD in formal. You need a PhD to build the tools, of course, but to apply formal, you don't need the expertise. The scalability comes in because these abstraction models simplify the state space, reduce a significant portion of the state space, which is irrelevant to proving the property or the checker that you're proving at that time.
I see. Now, tell me about your activities here at DAC. Are there any surprises? What are customers telling you?
Yeah, I mean, we've met a lot of new potential customers at DAC. And the thing which has surprised me is that, I mean, firstly, our experience with our current customers has been, there are some customers which have advanced to a stage where they're deploying roughly half of their verification resources at the block level verification, deploying formal, which is very far from where we were, I mean, a few years ago. And they're using a lot of end-to-end verification with formal, but it requires a lot of use of sophisticated methods, abstraction methods. But you can a lot of times replace simulation with formal, sometimes complement simulation with formal. And not every block is suitable for formal. The surprising thing that I've seen at DAC with many customers, which is not so surprising to our current customers, is that when you do end-to-end verification with formal, more than 95% of your code ends up being Verilog or System Verilog code, not SVA. And in fact, one sign that you're not using formal as much as it can be used is that most of your code, verification code, is SVA code. Okay. Because the actual assertion code is very small. Most of the code is scoreboards, reference models for end-to-end checking. And that was something which is kind of surprising for me to see and hear again and again with customers who've been applying formal for a while, but not really as pervasively as some of our other customers have been.
Interesting. Okay, thanks for sharing your insights, and I hope you have a great DAC.
Thank you so much, Joe.